I'm Candace Quates, an engineering manager at VMware, and I'm here today with my colleague Paul Ollie to talk about building and running enterprise-grade Spring applications in the cloud. Spring is a wildly popular Java development app framework that provides a simple, comprehensive, and modular way to build modern applications. Modern app architectures can improve scalability and velocity for developers, but implementing them can be challenging. With a Spring Boot architecture like this, establishing process and technology to do dynamic scaling of infrastructure can take a lot of effort. Many other things need to be taken care of, such as service discovery, configuration management, and managing the application lifecycle for security fixes. All this takes time away from building apps. To make it simpler to deploy and operate Spring applications, VMware and Microsoft created Azure Spring Cloud, now Azure Spring Apps, in 2019. Let's take a look at a few of the things that can make running enterprise Spring applications simpler. Paul Ollie is now going to show us Tanzu build service that is included with Azure Spring Apps Enterprise tier.
Hey everyone, I'm Paul Ollie. As Candace mentioned, I'm an engineer with VMware working on Azure Spring Apps Enterprise tier. So Azure Spring Apps Enterprise tier really enables teams to build, manage, and run their applications in the cloud. We're going to first explore that first phase, build, and we do that with Tanzu build service. Tanzu build service automates container creation, management, and governance at enterprise scale. It accomplishes using builders. A builder defines the stack and build packs used and processes building source code. They provide the build packs that run against the application and the operating system images upon which applications are built and run. Every new Azure Spring Apps instance comes with a default builder created. However, let's go ahead and create our own builder. So there's a few fields here. First, we're going to give our builder a name. Let's call this Hello Tanzu Build Service. Now we have two other options, the OS stack and build packs. First, let's choose our build packs. We can select from Java, .NET Core, Go, Node.js, and Python. For convenience, we might select all five. But let's say we know our organization only uses Java, .NET Core, and Node.js. So let's select only those three. This way, we know which application types are going to be built by Tanzu build service. Now that we've picked our build packs, let's go ahead and choose our OS stack. We have two options here. We have base and full. For most cases, base will be sufficient. However, some people might need full. Full is intended for Node.js and Python applications with many native extensions. Knowing that, we're going to select Bionic Base for our builder because we know we don't have many native extensions. Let's go ahead and save that now. So the next part of builders are bindings. Bindings allow Tanzu build service to inject necessary configuration into our applications to use other services. Our new builder is still being created, so let's go into the default builder to edit its bindings. We see there's several bindings available. We have application insights, app dynamic, Dynatrace, Elastic, and New Relic. From here, we can add new bindings, edit existing bindings, or remove existing bindings. For now, let's go ahead and edit the application insights binding. From here, we can edit the related properties to the binding. For application insights, we have sampling rate and the connection string. Azure Spring Apps creates the application insights instance for us and provides the connection string. So we're going to leave that alone. We can see that the sampling rate is set to 100%. If we want, we can edit this to lower value. Let's go ahead and edit this down. So you can see now we've changed it to 20, and we can save the binding to update the builder. Now that we've explored Tanzu build service and builders a bit, let's take a look at what a build looks like from GitHub Actions. So here we're looking at the build for a Java Spring Boot app inside of GitHub Actions. As we scroll through, we can see different output from the build process. Here we can see bindings for application insights that we just saw on the build service side, but now in the build. As we scroll, we can see the different build packs that are going to participate in the build process. And as we keep going, you can see the output from each build pack. Towards the end, we'll see the Gradle output building our application from the source code. And finally, after we've built the application and built the underlying container, we'll see the output from Azure Spring Cloud showing us a successful deployment. And we'll get the JSON describing our application and its different traits. Now that we've explored Tanzu Build Service a bit, I'm going to hand it back to Candace to talk about Spring Cloud Gateway.
Thanks, Paul. We're going to use some API routes from our Acme Fitness Store application to demonstrate functionality in Spring Cloud Gateway available in Azure Spring Apps Enterprise tier. Here's our storefront. We can see it's a catalog of stuff that you can use for working out. Here we have a catalog view of items. And here's a yoga mat, which is selling instant expert magic. That's quite funny. So here in the Azure portal, Spring Cloud Gateway is providing the routing for the front-end and back-end apps that make up the storefront. Here are apps in the Azure portal. And our landing page for Spring Cloud Gateway is here. Here's the URL that goes out to our service that we were looking at earlier. Here's the routes screen where we can see the routes loaded into our instance. If I scroll down a little bit, you should be able to see the routes for catalog. Here they are, catalog service. You can get products, and you can get products with an ID. Now, to look a little further at these routes, make them a little easier to see, I'm going to go into API portal. And in here, you can see all of the routes provided by the application. So let me scroll down a little bit here. You've got the cart. And here's the catalog. I'm going to scroll past the catalog a minute for the front end and the login and the users. I go back to the catalog. Let's go get products. Try it out and execute. This looks like it succeeded, and it did. Here's our yoga mat. It's made of magic. Now let's go into the details of what we can do in the JSON configuration for a route. From here, you've got, if you can see, we've got the predicates. So this is get products over here. And I wanted to add a rate limiting filter. This is one of the commercial filters available in Spring Cloud Gateway for Azure Spring Apps. And this rate limit right here will allow only 2 requests per every 10 seconds. Let's update that in the CLI. All right, and here's my route. I'm going to update my route config here. It's going to take a moment. We're going to go back into the portal and refresh it in just a second. It's really almost done if it says it's running. Let's pull out of here. All right. All right, here are our routes in the portal. I refresh, I should be able to see our catalog service. It's right down here, and it has a rate limiting filter enabled. Awesome. There's many other plugins available here, but these are just a couple I wanted to talk about. There are others, lots of things to rewrite headers. There's circuit breaker and token relay as well. Now, another thing we get access to in Spring Cloud Gateway in Azure Spring Apps is single sign-on. And it's a standard OIDC compliant identity provider. In here, I'm using Azure Active Directory, but you can use any OpenID compliant identity provider you have. There's just 4 parts of configurations: the scopes, client ID, secret, and the URI. And once you have that configuration, you can go into the routing rules and secure specific endpoints. So if I can see here, the cart service is enabled with SSO. We scroll down a little more and look for the identity service for the login. The identity service is also SSO enabled. And I can show that by logging in, and that is right here. So let's go over to the gateway and out to our fitness store. Let's hit the login button, and it should just work. Customer login. It's going to go back out and back through Azure Active Directory that I'm already logged into. And if I click the login button again, you can see that it's me here. Very cool. So I'm done here for now. Paul, I'm handing it over to you to talk about the application configuration service.
Thanks, Candace. Application configuration service allows us to manage our applications providing Kubernetes native resources. It's similar to Spring Cloud Config Server, but underneath the hood, it's working differently. Because it's providing Kubernetes native objects, there's no client library necessary for applications. Let's see how we can use application configuration service in Azure Spring Apps. Here we can see the configuration for application configuration service. Every configuration source requires a unique name, configuration patterns to load, and a URI for the Git repository containing our configuration. Optionally, we can also provide a label to specify our branch name and search paths of subdirectories in the Git repository. By default, application configuration services searches the root directory. Our patterns define what configuration can be used by our applications. Here we can see that we've got two patterns for catalog, default and key vaults. For an application to be able to use these configurations, we first need to bind it to application configuration service. Here we can see the different app bindings for app configuration service. We can bind or unbind applications. Here we can see that payment, identity, and catalog service are already bound. Let's go ahead and jump into catalog service. Now, from here we can go to configuration to see how it's configured. You can see that there's two different configuration options. It's the same two we saw earlier, catalog default and catalog key vaults. Now let's take a look at what configuration file is being used underneath the hood here. Here we can see we have a pretty standard Spring Boot configuration file. We've got two profiles. Here we have key vault, and we also have the default profile. In the default profile, we can see that the management endpoint has exposed all of the different actuators. Now let's take a look at how that configuration is being used in the running application. From here, we can see there's two different config files being loaded. We can see this first one is the key vault config file. And over here, we can see there's the default config file. And note, you can also see the same management endpoints configuration we saw earlier in our configuration file. This is just being provided to our app from application configuration service. Now I'm going to hand it back to Candace to go ahead and close this out.
Thanks, Paul. If you'd like to learn more, please go to via.vmw.com/asc-enterprise. Thank you.